In this supported study resource, we're going to be looking at the National 5 Applications of Mathematics course, focusing on the 2019 non-calculator paper 1. The learning intention for this session is to practice interpreting and extracting the required information from exam questions. We'll be applying numeracy strategies to those questions, and we will improve our confidence in dealing with our non-calculator exam questions. By the end of this session, you will have a clear strategy for approaching exam questions, and you will have practiced applying different numeracy strategies to exam-style questions. Throughout the lesson, you will see various different symbols on the slides to tell you what to do. Familiarise yourself with these. Before you get started, please make sure you have something to write with, something to write on, and a highlighter would be beneficial as we go through the questions. So we're going to be focusing on the 2019 non-calculator paper, and we're going to be focusing on questions where we need to apply numeracy skills, and quite often there's silly mistakes made with those, or alternatively where we really need to be careful in reading the question and interpreting it because we can make easy mistakes. So the first question we're going to be looking at is question 1. So your first step whenever you're tackling an exam question is the most obvious. Read the question and read it fully before you do anything. So you've got Helen, who makes and sells candles. These candles should be 22.5 centimetres tall. She rejects any candle that's out with the range of plus or minus 2 millimetres of this height. Below are the heights in centimetres of 10 candles chosen at random. Calculate the percentage of candles that she rejects. Once you have read that question, you're going to go back through the question and we're going to highlight those important pieces of information. And the reason for that is the applications course exam questions have a lot of words in them. There's a lot of information that you're given and it can sometimes be difficult to know what to do. So we're just going to digest that information a little bit. So Helen makes and sells candles. These candles should be 22.5 centimetres tall. She rejects any candle that's out with the range of plus or minus 2 millimetres of this height. Below are the heights in centimetres of 10 candles chosen at random, and we want to calculate the percentage of candles that she rejects. So I've highlighted all those key pieces of information. Now I'm just going to deal with that. So I'm told the candles need to be 22.5 centimetres tall, but there's a tolerance there. There is a range of plus or minus 2 millimetres. So all that means is that the candle can be 22.5 centimetres or 2 millimetres less or 2 millimetres more. So what I want to do is write down those limits. Now you can see that there's 3 marks available for this question. The first one is writing down those limits, and it's really important that you do that because if you don't write down the limits, your minimum and maximum values, and you make a mistake later on in the question, there's a really good chance that you're not going to get any marks whatsoever. Whereas if you put those limits in, you're getting that mark, or if you make a mistake with the limits, then you're going to get carry through marks for the rest of the question. Now the first thing that you should be alarmed by is the fact that I've got centimetres and millimetres. I've got different units there, which I don't want. So first thing I'm going to do is make sure that I've got consistent units. So I've got 22.5 centimetres. I could either write that in millimetres, or I've got 2 millimetres that I could write in centimetres. Now if we go back to our highlighted information, below are the heights in centimetres. So the heights of the candles are given in centimetres, so it makes sense for me to make sure that my tolerance is fully in centimetres. So I'm going to change that 2 millimetres. There's 10 millimetres in a centimetre, so I'm just going to divide that by 10. So I'm going to get 22.5 plus or minus 0.2 centimetres there, and that is my tolerance. Now so far I've not got any marks, but I'm making it very clear to myself what I need to do going forward. So to get my first mark, I'm going to make that statement. My minimum value will be the 22.5, take away the 0.2 centimetres to get 22.3 centimetres, and my maximum is 22.5 plus the 0.2 to get 22.7 centimetres. And there I've got my first mark for that question. Now your second mark for these types of questions always comes from identifying which ones are going to be accepted or rejected. So you could write out all of those values and write which ones are accepted or rejected, but it's enough for you to just make an indication on a question. So all I'm going to do is for the ones that are accepted, I'm going to put a tick, and for those that are rejected, I'm going to put a cross. Because my limits are 22.3 and to 22.7, anything that is 22.3 or 22.7 or in between will be accepted. Anything out with that range is rejected. So 22.2, first of all, too small. 22.6 is good, 22.5 is, 22.9 is too big, 22.3 is just intolerance, 21.6 is too small, 22.6 and 22.4 are intolerance, 22.7 is just intolerance, and then 22.8 is just too big. So there I would get my second mark just from showing those ticks and crosses. It also means, again, if you make a mistake at this point where you've maybe identified one incorrectly, then you are clearly showing how many you think are accepted and how many you think are rejected, which would allow you to get a carry through mark in the next part of finding the percentage. So that is 4 candles there that are rejected out of 10. So I'm going to just write that as a fraction. Now it's really important to emphasise the rejected part. They've said rejects twice in that question. A really common mistake with this question is to actually write how many are accepted, and that's just from not reading the question. It's a straightforward mark. If you can find the percentage of candles that are accepted, you can find the percentage of candles that are rejected. So there's no reason you should be getting this wrong. So making sure that you're going back, double checking what your question asked you for. It says calculate the percentage of candles that she rejects, and that should always be my last step, going back, making sure I've actually answered it. Now as for percentage, I've got 4 out of 10 here. Now the easiest way to write a fraction as a percentage is to get an equivalent fraction over 100, because the word percent means per 100. So if you've got a fraction with 100 on the bottom, then that is however many per 100, or however many percent that is on the top there is your numerator. So I've got 4 over 10. To get that as an equivalent fraction over 100, I'm going to times by 10. Whatever I do to the bottom, I'm also going to do to the top, so I'm just going to times 4 by 10, which will give me 40. And now I've got 40 per 100, or 40%. And I know that I've done what the question's asked for. I wanted the percentage of candles that are rejected, and that would be my third and final mark there for this question. So what I want you to do now is to pause the video and try these 2 questions, which are similar to the one we just went over. So they're both tolerance questions, both involve percentages at some point, which will test your numeracy skills. Once you're ready to check your answers, press play and the full worked solutions will be shown. The next question we're going to look at is question 2A. So Paul usually works 30 hours each week. He is paid time and a half for any additional hours that he works. His basic rate of pay is £12.50. Last week he worked a total of 37 hours. Calculate his gross pay for last week. So I've read my question over. The next thing I'm going to do is reread it, highlighting those important pieces of information. It's not a very big question, but there is a lot of information contained in it. So Paul usually works 30 hours each week. He is paid time and a half for any additional hours, and that's in bold there, so that's important. His basic rate of pay is £12.50, and last week he worked a total of 37 hours. So quite a few things given to me there. So I'm going to start by dealing with his basic rate. So I'm told that he works 30 hours a week and his basic rate is £12.50. So his basic wage is going to be £12.50 times by 30. Now here I'm multiplying a decimal by a 2-digit number, and it's really important that we know how to multiply and divide by numbers that have 2 digits. The way that I want to multiply by 30 is I want to break that down into its factors. So the factors of 30 would be 1 and 30, 2 and 15, 5 and 6. And I want to break that down into numbers that are easier. Like, I wouldn't multiply by 2 and 15 because 15 means that I'm still multiplying by a double digit. So I'm going to break this down into £12.50 times by 3 times by 10. And while 10 is also a double digit, it's quite straightforward for me to multiply by 10. I could multiply by 5 and then multiply my answer by 6, and that would be the same thing. Overall, if I times by 3 and then times by 10, I've actually multiplied the whole thing by 30. So I'm going to do £12.50 times by 3, or I could do times by 10 first, and then times by 3, as long as overall I've still multiplied by 30. So 3 times 0 gives me 0, 3 5s give me 15, carry my 1, 3 2s are 6, add on my 1 is 7, and then 3 times 1 is 3, and my decimal place will go here. So I've got £37.50, and then I'm multiplying that by 10. So you can think of shifting your place value of your number, or if you prefer to think of moving the decimal place, we can move that one place to the right. So I've got 37.5 becomes 375.0. Now, I don't have to write it as money now, as long as my end answer has my 2 decimal places and my pound sign, that's fine, but I'm just going to add it in anyway. So I've got my trailing 0 there and my pound sign. Now that I've got his basic wage, I'm going to deal with his overtime. I'm told he worked 37 hours. I've dealt with 30 of those hours. So all I'm going to do is account for the other 7 hours. So he's done 7 hours of overtime. But before I can work out how much he gets paid for that overtime, I need to work out what his overtime rate is. So his overtime rate is going to be £12.50 times by 1.5, time and a half. Now, I could multiply my decimals, but we tend to not like multiplying by decimals, and it opens up a lot of areas for making mistakes. So you can think of it as, well, it's his time, so he gets £12.50 for an hour, plus half of that. So I could do £12.50 divided by 2. So £12.50 divided by 2, I'm going to write as a step sum, 0, carry my 1, 12 divided by 2 is 6. Decimal place will go here, 5 divided by 2 is 2 with the remainder of 1, and then 10 divided by 2 is 5. So I've got £12.50 plus £6.25 there. And that's going to give me 5 and 2 is 7, the decimal point goes here, 2 and 6 is 8, and then 1 and 0 is 1. So his overtime rate is £18.75. Now that means to work out what his overtime pay is, or his overtime wage, I'm going to do that £18.75 and multiply that by the 7 hours that he's worked. So I'm doing £18.75 times by 7 hours. So 5 7s will give me 35, 7 7s are 49 plus my 3 is 52, 7 8s are 56, add on my 5 is 61, and then 7 1s is 7 plus my 6 is 13. My decimal point will go here. So I know that his overtime wage is £131.25. Now I was asked for his gross pay, so all I'm going to need to do is add his basic wage plus his overtime, and that will give me his gross pay. So 131.25 plus 375, making sure to line up my decimals there. That'll give me 5 plus 0 is 5, 2 and 0 is 2, 1 plus 5 is 6, 7 and 3 is 10, and then 3 and 1 is 4, add another 1 is 5. So I've got £506.25. All I'm going to do is go back, double check, have I dealt with all the information, have I answered the question, dealt with the 30 hours, time and a half, the additional hours was his overtime, his basic rate, and his 37 hours I've dealt with. Calculate his gross pay for last week, that's exactly what I've worked out. So I'm happy with that question. And your marks for this question come from working out the basic pay, so that £375, showing you know how to work out his overtime pay, and then your final answer for that there. So it's worth showing everything, every single step that you're taking, always showing every sum that you're doing. Okay, so I want you to pause the video now and try these 3 questions from exercise 2. So we're all on working out overtime and wages. Question 3 is a wee bit different. You'll need to work backwards for part of it, but they all rely on the fact that you need to either multiply or divide by double-digit numbers, which is the important thing that we're trying to pick up on from here. This is our numeracy skill we're working on. So if you wanted to multiply by 15, for example, we know that 3 times 5 is 15. So if you multiply by 3 first and then multiply your answer by 5, that means that overall you've multiplied by 15. And if you were wanting to divide, let's say we had to divide by 32, then we know that 4 times 8 is 32. So if we divide by 4 and then divide our answer by 8, that means overall we've divided by 32. And it's about making it easier for yourself. Multiplying and dividing by double digits, you want to instead multiply or divide by the factors of that number just to make everything a bit easier. So moving on to question 2b. Paul is buying a new TV. It is advertised at a price of £825. He decides to use a payment plan to buy the TV. The total cost of the TV using the payment plan is £845.80. The payments are calculated as follows. Deposit of 1/5 of the advertised price, 8 equal monthly instalments, final payment of £100. Calculate the monthly instalment. So going through that again, Paul is buying a new TV. It is advertised at a price of £825. He decides to use a payment plan to buy the TV. The total cost of the TV using the payment plan is £845.80. The payments are calculated as follows. Deposit of 1/5 of the advertised price. Advertised is there in bold, so that's important. Again, 8 equal monthly instalments, and a final payment of £100, and we have to calculate the monthly instalment. The reason I wanted to draw attention to this question in particular is to do with the deposit. So I want a deposit of 1/5 of the advertised price, not the payment plan price, but the advertised price. So my deposit is going to be 1/5 of £825, which I'll find by doing 825 divided by 5 times by 1. So 825 divided by 5, it's going to be 1 with the remainder of 3, and then 32 divided by 5 is 6 with the remainder of 2, and 25 divided by 5 is 5. And then 165 times by 1 would be £165 for my deposit. Now I want to find the monthly instalment. I've dealt with the deposit, but I've not dealt with the final payment. Now the final payment is not included in those 8 equal monthly instalments. I pay my deposit, then I make these 8 equal monthly instalments, and then at the end of the 8 equal monthly instalments I've got £100 that I'm then going to pay off. As it's not counted in my 8 equal monthly instalments, I'm going to have to get rid of that final payment there. I'm going to have to account for the fact that that is totally separate. So to work out how much the 8 equal monthly instalments are, I'm going to do the total of £845.80, take away my £165 plus that £100 final payment. So what I'm going to be doing, £845.80 take away £265. So 0 take away 0 is 0, 8 take away 0 is 8, decimals line up, 5 take away 5 is 0, 4 take away 6 I can't do, so I'm going to borrow from the 8 to make that 7, or really 700, and that's going to become 14, or really 140. So 14 take away 6 is going to leave me with 8, and then 7 take away 2 leaves me with 5. So my 8 equal monthly instalments in total are going to be £580.80. So I've dealt with that final payment and the deposit. Last but not least, I want to work out what one instalment is. And to do that, I'm going to do £580.80 divided by those 8 instalments. I'm just going to do that as a step sum. £5.80, £580.80 divided by 8, 0, 58, well 7 eighths is 56, so I've got a remainder of 2. 20 divided by 8, 16 is 2 eighths, and that would give me a remainder of 4. Decimal go here, 48 divided by 8 is 6, and then 0 divided by 8 is 0. So one monthly instalment is £72.60. I've dealt with my 8 equal monthly instalments. I'm just going to double check, have I dealt with all my information? I've dealt with the advertised price, I've dealt with the full price, got the deposit, the 8 equal monthly instalments, the final payment. So there's no information the question's given me that I've not dealt with. Always go back and double check, because that'll give you a hint if you've missed something out or made a mistake. And then I'm checking, have I answered the question, asked me to calculate the monthly instalment. I've worked out what the price of one instalment is, my £72.60. And so I am happy with that question. And my marks for that question would come from working out my deposit here of the advertised price, not the payment plan price, working out how much is left to pay with the 8 equal monthly instalments, and then finally working out my instalment there. Now, even if you made a mistake up here and used the payment plan price, there's still the chance of picking up these 2 marks as carry-throughs. So again, always important to show all of your working and where you're getting your amounts from. Now, I've not got any questions for you to practice that are similar to this one, just because the emphasis of this question was on making sure that you're reading that and picking up on the advertised price and not the payment plan price. So we're going to move on to our next question. The next question we're going to be looking at is question 6. So you're asked to write the following values in order from greatest to least: 0.388, 3/8, 38.38%, and 0.39, and you're asked to justify your answer. So write the following values in order from greatest to least, and I've got my values there, not a lot for me to highlight. So here I've got some decimals, a fraction and a percentage, and what you want to be able to do is to compare these. So you're going to have them all as either percentages or decimals or even fractions. Now, the easiest thing to go with here would be decimals. So I've got 0.388, so I'm not going to have to do anything with that. 3/8 means 3 divided by 8, so that's all I'm going to do. I'm going to work out what 3 divided by 8 is. So I'm just going to write it as a step sum. 3 divided by 8, well, 3 divided by 8 is 0, and then I've got my remainder of 3, so I'm going to add my decimal point and my 0 and carry it, so it becomes 0.30, add my decimal at the top. 30 divided by 8, well, I know that 3/8 are 24, so I've got a remainder of 6, that carries me onto my 0. 60 divided by 8, well, 56 is 7/8, so then I would have a remainder of 4. I'd add my 0 again. 40 divided by 8 is then 5. So I've got 0.375 for my second amount there. Then we've got 38.838%. So nice and straightforward. To go from a percentage to a decimal, I divide by 100, which we should already know. So I'm just going to divide that by 100, and that would give me 0.3838 as a decimal. And then 0.39 is also as a decimal. Now, all you need to do is now write them from greatest to least. Remember that, not least to greatest. That's important. The biggest mistake with questions involving decimals that people make is assuming that a longer number is a bigger number. all I'm going to do is I'm going to write out those three numbers. So I've got 0.388, 0.375, and I'm just lining up my decimal points here. 0.3838, and then 0.39. And by lining them up like this, it allows me to compare these numbers a lot easier. So if I look at my tenths here, I can see that I've got 3 for all of my tenths. So as far as I'm concerned, considering the tenths are all the same. So I'm going to look at my hundredths. So looking at my hundredths, my greatest number here is going to be 0.39. 8789, it's the largest number in the hundreds there. So I've dealt with that number. I'm going to go back to the tenths. So I've got 8, 7 and 8. So I know that my next one is going to be either the first number or the third number. So I'm going to move on and look at my thousandths now. I've got 8, 5, 3. So 8 is my greatest number there. So my next number is going to be 0.388. And I've dealt with that number. Crossing them off as I'm going just to keep myself right. Then again, I'm looking both 3 in the tenths, 7 and 8 in the hundreds. So because this number is bigger, I know my next number is 0.3838, and then that will leave me with 0.375. And I'm going to go back, double check my question. Did I do what I was asked for? Write the following values in order from greatest to least. Justify your answer. So this is my greatest, and this is my least. And my justification here is the fact that I've managed to write them all as decimals. So I don't need to do anything else for that question. I'm perfectly happy with that. So our numeracy skills to focus on there is knowing how to go from fractions to percentages to decimals. So a fraction is just the top divided by the bottom. To go from a percentage to a decimal, we're dividing by 100. Nice and straightforward. And your marks for that question work out that you get your first mark for showing a clear strategy and process, that you know how you're going to be able to compare them. And then your second mark comes from converting those 3 8s there. And if you don't show your working, so if you just go straight to showing that order, then you can only get 1 out of 2 marks. So show that working, show the conversion, make sure that you're getting all of those marks for that question. For exercise 3, I want you to go through this table here and fill in the missing values by converting between percentages, decimals and fractions, because this is an important numeracy skill that you could be asked to utilise throughout your exam in various different questions. So pause the video, try the questions, and when you're ready, play it again and check your answers. So next we're going to look at question 10. A basic cookie dough mix requires butter, sugar, flour and chocolate chips. 1/6 of the mix is butter, 1/3 of the mix is sugar, 1/4 of the mix is chocolate chips, the rest of the mix is flour. Calculate the fraction of the mix that is flour. So going back over that, my important pieces of information, I've got 1/6 of the mix is butter, 1/3 of the mix is sugar, and 1/4 of the mix is chocolate chips, and I want to work out the rest of the mix, which is flour. So your whole mix, the whole cookie dough mix, is our one whole, I'd refer to it as. We know 1/6 of that's butter, 1/3 sugar, and 1/4 is chocolate chips. That's what we know, and whatever's left over is going to be flour. So first thing I'm going to need to do is add the butter, sugar and chocolate chips together to work out what fraction of the mix is butter, sugar or chocolate chips. So I'm going to do 1/6 plus 1/3 plus 1/4. So for me to add or take away fractions, you need to remember that you need the same denominator for those fractions. So I need a common denominator. You could treat these as 2 separate questions and do 1/6 plus 1/3 and then do your answer plus 1/4. Or you could work out what my lowest common multiple of 6, 3 and 4 would be. And what I mean is, if I was to go through the 6, 3 and 4 times tables, what's the first number that is in all of them as an answer? And that would be 12. So what I want to do is I want to manipulate these fractions. I want to get equivalent fractions where the denominator is 12 for each. So I want something over 12 plus something over 12 plus something over 12. So 1/6, to get 12 on the bottom of that, I would need to multiply that by 2. So I'm going to times the top by 2. So I'm going to have 2/12. 1/3, I would need to multiply 3 by 4 to get 12 on the bottom there. So I'm going to times the top by 4. And then 1/4, I would need to times by 3 on the top and bottom to get 12 on the bottom there. So I'm going to get 3/12. And from there, when my denominator is the same, I've got 2/12 plus 4/12 plus 3/12. So in total there, I've got 9/12 of the mixture. So 9/12 is the fraction that I know. The butter, sugar and chocolate chips all added together. Whatever's left is the flour. And remember we said the dough is 1 whole. So I could write that as 1 over 1. So any number you can write as a fraction over 1. Or I could write that as 12 over 12. So it's still 1 whole, but that's going to allow me to do 12/12 take away 9/12. 12 take away 9 gives me 3, and that would be 12ths. So I know that what's left over is 3/12. So flour is 3/12 of the mixture. Now, as we should with any fractions question, I'm just going to simplify that so I can divide the top and bottom there by 3. And that'll give me 1/4. So 1/4 of the mixture that's left is flour. And our marks there would come from getting our common denominator of 12 first, then working out what our numerator should be and adding them to get the 9/12. And then my third mark would be taken away from the 1 whole to get the 3/12 or the 1/4 there. So this question is good because there's been quite a few similar to it in past papers and the specimen paper. And they've all been quite similar where you're adding the fractions that you've got together and taking away from 1 whole. So we're going to practice that. So for exercise 4, you're going to work through these 2 questions that are quite similar to the one we've just done. The first one's from the 2018 past paper and the other is from the specimen paper. And we're going to focus on those numeracy skills of being able to add and subtract fractions, making sure that you're getting a common denominator. So that's our important thing to remember with adding and taking away fractions. So pause the video, try the questions, and then resume the video when you're ready to check your answers. Moving on, we're going to look at question 11. Mary gave some money to 4 of her nieces. It was shared in proportion to their ages. Jane's 4, Heather's 11, Laura 9, Kate 6. Kate's share was £1,950. Calculate the total amount Mary gifted her nieces. So going back through that question, Mary gave some money to 4 of her nieces. It was shared in proportion to their ages. So that would mean the older they are, the more money they get. We've got Jane's 4, Heather's 11, Laura's 9, and Kate is 6. And we know that Kate shares £1,950. And we want to calculate the total amount that Mary gifted her nieces. So there's 2 ways I could approach this question. The first would be working out everyone's amount that they get and then adding them all together. Or I could deal with the fact that I only need the total. So for every year of age here, they get a certain amount of money. So a 1-year-old would get this amount, a 2-year-old would get double that, a 3-year-old would get triple that, 4-year-old would get 4 times that, and so on. Now, if I can work out what the total age of all 4 nieces is, then I could just work out an equivalent. What would a person who's that age get from Mary? So I'm going to treat this like a ratio question. Ratio and proportion are very, very similar. So I've got Jane, who is 4. I've got Heather, who is 11. Laura is 9 and Kate is 6. So the total age of all of the nieces then will just be 4 plus 11 plus 9 plus 6. So I've got 20, 24, 30. So in total there's 30 years worth of money being shared out. Now I know that Kate gets paid £1,950. So I want to work out basically how much Kate's got for every 1 year of her age. And to do that I'm going to think, well, what would I have to times 6 by to get 1,950? Or what is 1,950 divided by 6? So I'm basically sharing that money out for every year of age there. So that'll be 0, carry my 1, 18 is 3 6s with a remainder of 1, 12 is 2 6s, and we've got a remainder of 3, and 30 divided by 6 is 5. So I know for every year of age, someone is getting £325. Now, if in total there are 30 years between them all, then I'm just going to do 325 times 30 to work out what that total is there. So I'm timesing that by 30 to get my amount here. Now, from earlier on in this video, we should know that to times by 30, I could times by the factors of 30. So I'm going to do 325 times 3, then times by 10. So 325 times 3, do that as a column sum. 3 5s are 15, 3 2s are 6, add my 1 7, 3 3s are 9. And then I'm doing 975 times by 10. And that's going to give me a total there of £9,750 being shared out amongst everyone. And so you can see that I'm using that skill again of having to multiply by a 2-digit number. So it's a really important one that we can master. My first mark there would come from working out what one share is. So how much is 1 year worth, basically. So 325 would be my first mark. My second mark would be working out the total ages, and then my third mark would be working out that 9,750. Or alternatively, if you had done it the other way and worked out how much each of them would have got, so you would end up with Jane was 1,300, Heather 3,575, and Laura 2,925. So getting the 3 of those other nieces' amounts would be that second mark, and then your third mark would come from adding the 3 of those with the 1,950. However, that's a lot more working for that question, so we want to try and minimise our risk of making silly mistakes with our numeracy. So always kind of look for the easier way that's still going to get you those marks. So for the next exercise, I've got 2 questions here that are fairly similar. So question 1 is a proportion question, question 2 is ratio. However, as I mentioned, they're very, very similar. You can work them as a ratio question, both of them. The first one is non-calculator from an old life skills paper. Question 2 is technically from a calculator paper. However, it should be manageable, non-calculator. There's nothing too difficult about those numbers there. So give those 2 a try. Pause the video, and then once you're ready to check your answers, play the video. So the next question I would like to look at is question 12. Kieran and Gemma have each set themselves a monthly electricity allowance. Kieran has set himself an allowance of £42. Gemma has set herself an allowance of £49. At the end of July, their smart meters recorded that Kieran had used £15 of his allowance. Gemma had used £21 of her allowance. Determine who had used a greater proportion of their allowance. Use your working to justify your answer. So I've read through the question. A lot of information there, so I'm going to highlight those bits that are important. So Kieran and Gemma have each set themselves a monthly electricity allowance. Kieran has set himself an allowance of £42. Gemma has an allowance of £49. At the end of July, their smart meters recorded that Kieran had used £15. and Gemma had used £21 of her allowance. Determine who had the greater proportion of their allowance. And we're using working to justify our answer. Now, all that means is I want to find out in terms of how much they were allowing for, who's used the greatest proportion of that. So, Kieran has used £15 out of 42. So I'm just going to write that as a fraction to show that. Gemma has used £21 out of her 49. So Kieran's used less, however, his allowance is less. And Gemma has used more, but her allowance is more. So what I want to do is easily compare those amounts. And to do that, since I've got them as fractions here, what I want to do is I want to get a fraction with the same denominator there, so I can easily compare them. Now, first of all, I can simplify both of those fractions, so that's exactly what I'm going to do with them. So 15 and 42, I can divide both of those by 3. And 21 and 49, I can divide both of those by 7. So I'm going to get 15 divided by 3 will give me 5. 42 divided by 3, 30 is 10, and then another 12 would be 4, so 14. So 5 14ths. And Gemma, 21 divided by 7 is 3, and 49 divided by 7 is 7. Now, all I've done is simplified both those fractions. I don't have a common denominator, so I can't compare them as they are. However, I can easily manipulate Gemma's fraction here, the 3 over 7, so that it is also over a denominator of 14. So I'm going to times this by 2 on the top and bottom. So I'm going to get 3 times 2 is 6, 7 times 2 is 14. And this allows me to now compare Kieran and Gemma's allowance. So Kieran used 5/14 of his allowance, while Gemma used 6/14 of her allowance. Determine who had used a greater proportion of their allowance. So since Gemma's fraction is higher, then it's going to be Gemma. So I'm just going to make a statement. So Gemma used a greater proportion since 6/14 is greater than 5/14. And I've just used my inequality symbol there. You could write the words greater than. Going back to my question, I was to determine who used a greater proportion of their allowance. I've said it's Gemma. Use your working to justify your answer. My working's there. It shows that I've got both those fractions with the same denominator so that I can easily compare them there. And so I've done everything this question has asked for. And my marks here would come from starting the question off by showing those fractions, the 15 out of 42 and the 21 out of 49. My second one would be getting them to a point where I could compare them. Now, I went for fractions because numeracy wise, that's the easiest thing to do here. You could have went to decimals, so you could have done 15 divided by 42 and 21 divided by 49. You could have done that by using your factors of 42 and then 49. And that would have given you a decimal, and then it would have been whoever had a higher decimal you could have compared, or you could have even used percentages and worked out what percentage of each of their allowances they had used. So our last exercise, exercise 6, is looking at questions where we do need to compare fractions. So the first one from the specimen paper for the life skills course is fairly similar, only this time instead of simplifying, you're going to have to create an equivalent fraction with a bigger denominator there. And question 2 is actually a gradient question, but an element of it involves you comparing fractions. So this is a good example of where this skill can be applied elsewhere in the course. And this one's from the 2018 past paper, and it's paper 1 as well. So pause the video, try the questions, and once you've tried those, you can resume the video to see the worked solutions. So throughout this video we have practiced interpreting and extracting the information we need to approach exam questions. We've applied various different numeracy strategies to these exam questions, and we've hopefully improved our confidence in dealing with those non-calculator exam questions. At the beginning of the video we said our success criteria would be having a clear strategy for approaching exam questions, and that is read the question, reread it, highlighting those important pieces of information, think up a strategy for using that information and how to get to what you want, show all of the working that you're doing, and always go back and reread the question to ensure you've answered it, and then add any units or round if you need to. We also said we would practice applying numeracy strategies to exam style questions. So examples of the numeracy strategies that we have looked at are multiplying and dividing by 2-digit numbers by multiplying or dividing by that number's factors, which is a really important, useful skill to be able to use. It will come up time and time again. We looked at changing between decimals, percentages and fractions in order to be able to compare them. We looked at comparing fractions by manipulating them so that they have the same numerator or denominator to allow for that comparison. And we also looked at being able to add and subtract fractions, which we need a common denominator for. So these are some of our common numeracy strategies that come up time and time again in the exams and are important for you to be able to use. So your next steps in preparing for your exam this year are to attempt more practice in past papers under time conditions and approaching them in the way that we spoke about, reading the question, rereading and so on, and apply those numeracy strategies that we've looked at today as well.